we are going to learn a way to model the atom called an Aufbau sequence. You do know how to do this. This Aufbau sequence is straight from the atomic flower, but you will never have to draw the atomic flower. I just wanted to show it to you so you would have a better understanding of what's going on. You will have to do Aufbau sequences, okay? But they're very, very simple. An Aufbau sequence takes into account not just the level, the energy level of electrons, but also the type of orbital that the electrons are falling into. However, looking at the periodic table makes Aufbau sequences very, very easy to write. Let me show you. Remember, this section of the table, and if you're at home, you need to write this on your colored table. These two are called the S's. These 6 over here are called the P's, okay? These are the P orbitals. And then in the middle, the transition elements, these are called the D's, all right? And then you won't have to write any of these, but if you write an Aufbau sequence including the inner transition metals, you would need to know they were called the F's, okay? So looking at the real periodic table, you have these 2 are the S's, these 6 are the P's, these 10 in the middle are the D's, and these 14 on the bottom are the F's, okay? So let's quickly write an Aufbau sequence for an element, okay? I'll tell you what, I'm going to write S, P, D, and F on here as we do it. How about, let's do a simple one. Let's do aluminium, okay? Here's aluminium. All you do is write down the number, level, and type of orbital you're going through until you get to aluminum. And we're going to go left to right, top to bottom, like we're reading a book. So watch this. Here is ring 1. For these models, helium really acts like it's sitting right here. And you should be like, oh, Mr. Perkins, I remember when we had to cut the models out and we put them on the blank board, we discussed the fact that helium could really fit right here. Do you remember that? Okay? So that's coming into play now. Here we go. We're going to do aluminum. 1. How many S's did I go by? How many S's are here? 2. So you write 1, S, 2. Now the whole first ring is done. Now check this out. Now we're in the second energy level, or second period, or second orbital, okay? And we go by 2. How many S's are here? So 2s2. We went through 2 s2 orbitals. And then now we're going to go over here, and we're in the P's. We're on level 2. How many P's are here? 1, 2, 3, 4, 5, 6. So then you write 2, that's the energy level we're in. P, that's the type of orbital. 6, that's how many you went past. And now we're done with the whole second energy level. Now we're down to the third period, or third energy level. How many S's are here? 2. 3s2. And then now we go over here to aluminum. It is in the third energy level. It is a P, and it is the first one. So this is an Aufbau sequence for aluminum. If you're at home, you can watch this over and over, right? Does that make sense to you, what I wrote down? I wrote 1s2, 2s2, 2p6, 3s2, 3p1. Let's do another one real quick, right? All right. How about I choose is this vanadium? Get my metal strip. Let's do vanadium right here, okay? We're going to do an Aufbau sequence for vanadium. Ready? Here we go. We're going to go top to bottom, left to right. Energy level 1, there are 2 S's, 1 S2. Now we're done with the whole energy level. Now we're down to the second energy level. We go through 2 S's, second energy level, S orbitals, there's 2 of them. Now we're over here, we're in the second energy level 2. These are the P's, 2p6, 2p6, because there's 1, 2, 3, 4, 5, 6 of them, right? Now we're to the third energy level. There are 2 of those, 3s2, and now we're over here. We're still in the 3s. What are these? What letter are these? P's. So 3p, 1, 2, 3, 4, 5, 6. 3p6. Now we're down to here, 4. How many S's are there? 2, 4, S2. And now we have one more thing to write. This guy right here. You would think it was 4D2, but where would you put this dot on the Bohr model? Would you put it in the 4th ring or would you put it in the 3rd ring? So these in the middle, remember I said they act like they're up 1? So vanadium is not in 4D2. Vanadium acts like it's up here, 3D2. See, now this Aufbau sequence matches the atomic flower and matches the Bohr models that you made. Does that make sense? So when you get to here, it looks like it's 4D2, but it's 3D2. Does that make sense to you? All right, if you're at home, you can play this over and over. This is pretty straightforward. These are the S's, P's, D's, F. You just write down how many boxes you go by on your way to getting to your element. Does that make sense? Everybody with me? Okay.